PPTC 121. Power Plant Steam Systems Session 13. Boiler Accessories. The purpose of this presentation is to further explain the equipment needed to measure parameters, to further explain power plant control, to explain safety valve code requirements, to further explain boiler blowdown and how it works, and to explain additional types of valving. The basic types of steam plant measurement are 1. The measurement of level, 2. The measurement of pressure, and 3. Temperature measurement. There are others, but these are the most important. Now let's discuss level measurement. The steam drum level is the most important measurement for the safe and reliable operation of a boiler. Too low and the boiler walls fail, and too high, water overflows to the turbine. Both of these create extreme failures of the equipment. So the American Society of Mechanical Engineers has set some requirements for drum level. ISME requirements for drum level monitoring. For all modern boiler designs, drum level instrumentation must be in accordance with the ASME boiler and pressure vessel code. For pressures below 400 pounds per square inch gauge, at least one direct reading gauge is required. For pressures above 400 pounds per square inch gauge, 2 direct reading gauges, or 1 direct reading, and 2 remote reading gauges are required. The basic types of level measurement for a steam drums are gauge glass, water column, bicolor gauge, fiber optics, and electrode alarms. Each one may have an advantage over the other. Gauge glasses can get dirty and are hard to see without additional lighting. Water columns only work in very low pressures. Bicolor gauges have been used for years in combination with closed-circuit television. Fiber optics provide a direct view of a lighted gauge glass, and electrode alarms work on the conductivity of the water in the column to light a light in the control room. Control of the condensate and feedwater systems is important in controlling the level in the deaerator and steam drum. There are 2 types of control of deaerator and steam drum levels. They are single element and 3-element control. Here is shown a drawing of single element control. In this type of control, the steam drum level is the only factor in controlling the feedwater valve. Single element control is used during startup operation. Here is shown a drawing of the 3-element control. In this type of control, the steam drum level is used in combination with a comparison between the steam flow and the feedwater flow. The comparison provides a feed-forward signal to the control system for the feedwater control valve to head off a level change before the level actually changes, and thus gives a faster responding control mechanism during online operations. Here is another drawing of 3-element control of steam drum level. What causes the steam drum level to change? 1. Swelling results when the boiler load increases and the saturated vapor increases. During this condition, the drum level increases temporarily. 2. Shrinkage results when the boiler load decreases and the saturated vapor decreases. This condition causes the drum level to decrease temporarily. And 3. A change in load creates a discrepancy between the steam flow and the feedwater flow. The feedwater control system is designed to maintain the water in the steam drum at an acceptable level during normal operations. And now let's discuss pressure measurement. The burden tube type of instrument is the earliest type of pressure measurement, and manometers can be used to measure lower pressures, such as atmospheric. Pressure measuring instruments are of various forms, and these depend upon magnitude of the pressure, the desired accuracy, and the application. Manometers are considered an accurate means for pressure differential pressure measurement such as condenser pressure. Steam gauges used in the modern plant are usually the burden tube type. They operate by the pressure in the tube having a tendency to straighten the tube. The steam gauge for small boilers are usually mounted directly on top of the water column, therefore the gauge reads the correct pressure. However, on many installations the gauge is brought down to the operating level. At this level the gauge reads steam pressure and the hydraulic head of the water line. So what is the drum pressure? If there is a gauge located 45 feet below a steam drum, when the gauge is reading 175 pounds per square inch, there is 0.433 pounds per square inch per foot of water. Here is the calculation. 45 feet times 0.433 pounds per square inch per foot of water equals 19.5 pounds per square inch. Then 175 pounds per square inch minus 19.5 pounds per square inch equals 155.5 pounds per square inch pressure in the drum. And now for temperature measurement. Temperature measurements are normally done in a power plant with a thermocouple. A thermocouple is the junction of two different metals which, if maintained at a different temperature than a reference junction, creates an EMF. This EMF is small and is read locally by some electronics and relayed either digitally or by analog signal to the plant computer and displayed in the control room. Here is a picture of a thermocouple with its connector. Here are the ASME code requirements for safety valves. One or more safety valves on a boiler proper shall be set at or below the maximum allowable working pressure. 2. All safety valves shall be constructed so that failure of any part cannot obstruct the free and full discharge of steam from the valves. 3. Safety valves shall be connected to the boiler independently of any other steam connection and attached as closely as possible to the boiler. 4. No valve of any type shall be placed between the required safety valve and the boiler, or between the discharge pipe between the safety valve and the atmosphere. 5. Safety valves are intended to open or close within a narrow pressure range. and therefore, safety valve installations require careful and accurate design for both inlet and discharge piping. 6. The discharge piping from safety valves should be equal to or larger than the nominal valve outlet, and should be as simple and direct as possible. 7. The safety valves shall have proper clearances from such areas as platforms and 8. Safety valves shall operate without chattering, and shall be set and adjusted to close after blowing down not more than 4% of the set pressure, but not less than 2 psi in any case. Which safety valve should open first? The safety valve on the superheater outlet should open first. This produces steam flow through the superheater and prevents superheater tubes from being damaged by high temperatures. What are safety valve testing procedures? Safety valve testing 1. Can be accomplished by slowly raising the steam pressure and noting the pressure gauge reading when popping pressure is reached. 2. At the instant the valve pops, read the pressure gauge, after which the rate of steaming should be reduced. 3. Again read the pressure gauge when the valve closes. Do not the blowback, and 4. Continued and repeated the adjustments should be made to adjust the spring and blowback ring to obtain the desired popping pressure and blowback. What is boiler blowdown and why is it important? Water fed to the boiler contains impurities in the form of suspended and dissolved solids. A large portion of these impurities is left behind when the steam leaves the boiler. As a result, the solids build up in the boiler water. In order to keep this concentration to a minimum, it is necessary to blow down the boiler periodically or continuously. What are the types of boiler blowdown? There are 2 types of blowdown. 1. The continuous blowdown consists of a pipe entering the drum at approximately the normal water level with the pipe fixed in location. It has a swivel joint on the short piece of pipe, the free end being held at the surface by a float. Surface blowdown is usually made on a continuous basis. 2 is the mass blowdown or automatic blowdown, which is used intermittently for high drum levels and if solids get too high in the boiler water. A non-return valve is a safeguard in a steam power plant where more than one boiler is connected to a common main steam line. An example of this type of installation is at the Michigan City Generating Station, where on units 2 and 3 are 3 boilers headed together feeding 2 turbines. With this valve a boiler can be removed from service, while other boilers continue to operate. The boiler stop valve will close instantly on loss of boiler pressure, such as one caused by a tube leak, and it isolates the boiler to which it is attached when the pressure within the boiler drops below the pressure in the main steam line. Unit 15 at the RM Shuffer station has a boiler stop valve. It also provides the ability to hydrostatically test the boiler without filling the steam lines with water. The plant steam piping must be of sufficient thickness to withstand the internal pressure and shock due to velocity of the steam passing through it, and prior to its initial operation, the steam lines must be blown to clean the line of dirt and any debris that remains after construction. During every startup, the steam lines must be thoroughly emptied of water to prevent water hammer, which can severely damage these pipes. For steam piping operating over 800 degrees Fahrenheit, damage can occur due to creep, cycle, fatigue, erosion, and corrosion, and the condition of the piping must be evaluated periodically during scheduled maintenance of the boiler. Valves used frequently in a power plant are gate, globe valves, and check valves. Gate valves consists of a gate that can be raised or lowered into a passageway. This valve should be just used for on or off flow conditions. Globe valves consists of a plug or disc that is forced into a tapered hole. This valve can be used to restrict or throttle flow. Check valves is a modified globe valve without a stem. It is arranged in such a way that gravity closes the valve, preventing backflow. There are 3 types of controlled valve systems: off-on control, positioning, and metering. Off-on control is where the valve is controlled either open or closed. A positioning control system is a system where a specific required output is compared to an actual output and adjustments are made to achieve the desired output from the control valve. This essentially is an analog system. With metering control, the same thing is done digitally. For pneumatic system, all instruments in the control loop are air-activated measurements from central points. There is the controller which generates air signal, which is transmitted to the diaphragm of the control valve actuation to move the valve. Why would you want to have an automatic control system? Automatic combustion control is justified by the benefits it provides. 1. It adds safety to the plant operation. 2. It improves the operation and the efficiency of the plant. 3. It reduces the manpower requirements. 4. It lowers the fuel costs. 5. And more. A digital control system, DCS, is justified compared to analog control system by the following reasons. 1. Provides faster plant startup. 2. Has higher availability. 3. Creates even greater thermal efficiency. 4. Helps improve plant emissions. 5. Has lower maintenance costs. And 6. Lower operating costs.